Hopefully I won't get too emotional, but I want to talk about being emotional creatures. And the context here this week has been very interesting because there's been a pile of talks about programmers are human beings. Hands up if you learned that this week. Maybe the rest of you already knew. I am a code person. I pride myself on the fact that I write code every week. That's what it says in most of my bios. And when you've been doing it as long as I have, that's a non-trivial accomplishment. People want you to manage stuff and advise people and be wise, and all of that is fun. But I like to write code whenever I can. And so we're going to talk about code. We're also going to talk about humans. And we're going to talk about emotions. Who trusts emotions? Am I getting any hands? I'm getting a very small, slowly raised group of hands. Emotions are out-of-band interrupts. You're getting all this data, you're listening to people, you're reading stuff, there's things on your screen, your phone's in your pocket, and a signal comes in with no supporting data, just a conclusion. That's what an emotion is. It says, get out. It says, trust this person. It says, something's creepy here. I don't like what's happening. Or it says, relax, this is fine. Everything's okay. Some people, when they get that creeped out feeling, they leave. Some people, they tamp that down. They say, I'm not going to listen to that. That didn't come with numbers. That I have no observations to back up that this person is creepy. This person hasn't stabbed me yet. We should withhold judgment until the stabbing commences. I would argue that some of us have learned to trust those emotions, both the good and the bad ones, because of times that we didn't. And later in hindsight, we said, I should have known, right? Some people are very good at getting these signals for themselves. They pick these things up, they get this out-of-band interrupt, they think, this is fine, I can trust this person, I'm in a good place. They laugh, they smile, or they're scared, or they run away. And other people seem to just be blissfully unaware of some of those very same signals. It is my experience that people who aren't very good at it don't trust it. And they think that acting on an emotion is kind of cheating or shortcutting. Okay, you have no right to cut this date short because he hasn't stabbed you yet. But also you have no right to want to work at that place just because it felt warm and friendly and welcoming. You need to properly investigate whether that's a place to work or not. And it's cheating or shortcutting to rely on your emotions. You're cutting corners. You're not being rigorous. Let's talk about making a virtue out of necessity. I'm not very good at seeing those cues and getting those out-of-band interrupts and acting on them. So I'm going to say that doing that is wrong. It's a really clever trick, right? Like singing is terrible because I'm not good at it. Or drawing is stupid because I'm not good at it. And reacting to emotions is wrong. And this goes so far as to put that imposition on others. I'm sure you've worked at places where having any kind of emotion, much less acting on that emotion, was kind of forbidden. Not explicitly, but yeah, where's your data for that? I don't think you've proven that. I don't think that's a conclusion you're eligible to draw. Or that's a first world problem. Now, I've accused people of having first world problems. You know, they made my coffee wrong. I paid $5 for this coffee, and they put the wrong stuff in it. And someone says, you poor thing, you poor, poor thing. It's so awful your coffee was wrong. And it's like, yeah, I get it. Nobody actually died. But does that mean I'm really not allowed to ever be upset about things that upset me? Or we also cut each other down for being happy. right? If you're just, oh, look at that fangirling, you're squeeing, it's terrible, you don't get to enjoy things. And we enforce this norm. And I think specifically maybe this community, more than some younger programming languages, we enforce a norm that says no emotions. Okay, we're going to be logic. We're going to live in the matrix. Before we did Boolean logic, we did propositional logic. So as we have established, programmers are human beings. Human beings have emotions. You can't resist this next thing. You know what comes next. You don't want this next part to be true, but, right? Damn, she tricked us. Okay. Emotions are not for the weak. Emotions are for people, and since programmers are people, emotions are for programmers. And we've had some good talks about that, about the overall job of software development, managing, delivering, building relationships, getting paid. Emotions are super useful for this stuff. Remember that in addition to the I better get out because I might get stabbed emotion, it's also possible to evoke the I can trust this person emotion. This is actually really fine, not on fire fine, but really fine. Everything's going well. I'm on the right path. And when you can make people feel that way, you can win the meeting. When you're willing to listen not just to what people say, but how they say it. We were talking at one of the breaks about someone who once told me that he had checked with his wife and she said it was fine. And I'm like, was it fine or was it fine? What? No, she said it was fine. I'm sure it's fine. I don't know. What if it's fine? Then where will you be? So if you can listen to the difference between those two fines, again, you can win the meeting because you can say, wait, what's the problem? Why can't you do that? Why do you want that? Who would want that crazy thing? Tell me more. You can become someone who is seen as helpful and that can be counted on and as a valuable team member. And yeah, my definition of winning the meeting is the reason I don't object to being asked to take minutes. For those of you who haven't noticed, if there's 20 men and 1 woman in a room, someone will say, Kate, could you take the notes? Yeah. That's a thing. But you know what? The person who takes the notes wins the meeting. The person who writes down what's going to happen determines what's going to happen. So I don't mind that. But it's also about having the emotional strength to know who you can count on. Your teammates are probably not going to literally stab you, but they might tell you they'll do that thing and then not do it, right? And learning who you can count on and who you can't, and being strong enough to trust when trust is appropriate, these are emotional skills. And being someone who can be trusted and who emits that, that's an emotional skill. Now, the great thing about being here this week is that I'm not the first person to say these things. And that's terrific, because that's the last I want to say about those parts of emotions in software development. The not code parts. They're wonderful, they're real, they're powerful, and they're strong, but it's not what I want to show you. What I want to show you, you're supposed to come in last. Sorry about that. So I'll read you what it says. It says, making software would be so much easier without these pesky users and their illogical demands. Everything is easier when emotions don't get in the way. I love getting away from people and back to pure code because there are none of those feelings involved in code. It's just logical. I put the wrong on because people took pictures of the slide, an earlier version of it, and then argued with it. So look, none of this stuff is true. People say there are no emotions in code, but there are. In your code, in your if statement, in your for loop, in your calling of a function and returning from that function, there are emotions. And that's what I want to talk about. The other stuff is really important. There are other people you can hear that from. I can see emotions in C++ code, and I'm going to show them to you. And a disclaimer, you may not thank me. Who here has been offended and upset by commented out code? Why do we do that? Why do people leave code behind? I found this in the wild. It's a relatively tricky little if. There's a global, of course there's a global, and a member variable for these two properties, which I have slightly redacted to X and ABC. And in some cases, the global X may not be the same as the X that is in the member variable, or the current global ABC may not be the same as the member variable ABC. And apparently, at one time, when that happened, there was some special compensatory mechanism to deal with that in this system. And I don't want to tell you that they took the global away or that they took the member variable away, because I'm quite sure they did neither. But at least in this little corner of the code, they no longer needed this special little compensatory mechanism. So the person took away the body of the loop, but they didn't want to lose the if. Because there's ands and ors and brackets, right? That took some time to compose. So they just commented it out. And when I ask people why they comment out code, well, I'm not sure that I'm right. I might need it. There's no confidence striding forward, deleting it. No, I'm not sure. Then there's the blamey comment, right? Don't come to me if this is wrong. Come to Steve in accounting, right? This is my favorite of all the ones I found. I'll read it to you. The old commented out code declares a variable called nData and does not initialize it. And then afterwards it says, March 22nd, 03, feel free to do the math. This uninitialized was caught by Visual C++ 7. Okay, these people were moving up from 6, the generally revered best Visual C++ ever, to 7, which had the amazing ability to issue a warning if you had uninitialized variables. Now, the next line, they actually initialize nData to 0. Whew, that's a stretch, right? They're really going out on a limb with that. But they had to leave the comment, don't be mad. The compiler made me. I wasn't going to initialize it. Please don't come to me in code review and, don't at me, is what I'm saying. I had to. 16 years ago. And not only has that comment been sitting there for 16 years, but I did a search and there's dozens. Whoever's job it was went through, made all the warnings go away, and to their credit, they didn't pragma the warning or whatever. They actually fixed the problem. But they left the old line, because they've come in here like some heathen initializing integers to 0. They want you to know it wasn't their idea. They didn't want to. Please don't blame them. Sometimes we don't even bother commenting them out. We just leave them there. I know I don't call this function anymore, but we might call it later. I know I calculated all this stuff and I used up runtime performance cycles calculating stuff that I don't use, but I might need it. I can't be sure. I don't know that it's going to be okay. Sometimes it's not even that they look at it and think they still need it. They don't even look at it. They just change the algorithm a little bit so it doesn't use the current year anymore, but all the code that calculated the current year is still there. Or they replace that old current year mechanism that was making systems calls under Windows and whatever to some better, more modern library, but they leave all the old stuff there. They don't necessarily understand the old stuff, or they just can't take the time. It's working now. If I take another 5 minutes just to read it with my eyes and make sure that I understand what's happening and delete the extra stuff, that's 5 minutes I'm not spending on something else. Who's been in crunch? The middle of the room is crunchier, I gotta say, than the edges of the room. These are people who come on time and get the good seats because they've been hurt before. During crunch, you're like this, right? I'm working 12 hours a day. I have to wear a hello, my name is mummy or daddy when I go home. And I I'm not giving you 5 minutes. That's okay. But the rest of the time, what is it that this person thinks will happen to them if they're slow? If they take the time to clean up after themselves? The other thing I see a lot of in old code that's had 20 or more years of development is people following old patterns, right? So we start, of course, by declaring all the variables at the top of the function, as you do. That way later you can page up 15,000 lines to remind yourself what they were. But worse than that is, of course, these variable names, right? I don't know what happened on the first line. People were apparently thinking back then. C and N probably stand for something, I don't know what. But soon we just go, like, look at double D1, D2. You know, D is standing for double, right? I need a number. Double factor's not much better. And someone comes along, they're like, I also need a double. Comma D4, right? They don't stop and say, this ends with me. We're going to call our variables proper names. We're going to declare our variables closer to where we use them. I'm going to make this better. They just say, no, you know, the equivalent of when I was quite young, no one got fired for buying IBM. Then that became no one got fired for buying Microsoft. And it's still going to be no one got fired for doing it like the last person. So they just do it like the last person. Do you know what this all has in common? These all show fear. When I read this code, I see a scared person. They're doing the wrong thing. They probably even know it's the wrong thing. They are afraid. In fact, there's so much fear in code, I need another whole set of slides. Redundant checking. Come on, you've read this. If some pointer, delete the pointer, yes? Some of you have done it, copied it maybe from another person before you went, wait. Deleting a null pointer is a no-op. Why am I using up compiler cycles and runtime cycles checking something that doesn't matter? Well, because everywhere else you do anything with a null pointer, very bad things happen. And so you've been taught to be afraid and to always check pointers. A question right here.
Because Visual C++ blocks the global heap before checking for the null pointer.
There may be some, indeed, compiler-specific oddities that induce this fear as well. But I also see this with checking things you should be sure of from elsewhere in the code. Right? This function takes, I don't know, some money amount which has to be positive. And we've all done all the architecture, and there's other functions elsewhere that check and validate, but we check and validate too. Sometimes we check and validate because we just can't keep track. How am I supposed to remember that I checked it in the other function? But other times, I have been told, I don't write the code that does the check. So at any given time, that code might stop checking properly. The only one I can count on is me. Now think about this if you are a manager. Think about this if you pay for CPU time, and as we move into the cloud, we pay for CPU time. At runtime, your code is checking something that should have already been checked because your developers aren't willing to write tests. So every single time the application runs, it's going to do that if over and over again because your coworkers don't trust each other and don't even verify their lack of trust with tests. They just throw in a runtime check out of fear. It's also part of why people do things by hand. It's not the only reason. But sometimes when I see a for loop, when I see someone not using an algorithm, when I see someone doing it the slow way, they can't trust someone else's code. They were hurt by a library once. In fact, they tell me about it. They tell me about that time in 1993 when they used someone else's sorting code and it wasn't very performant. Oh yeah, that's completely relevant today. Good catch. Thanks for saving us from that. But they don't always articulate it. They just feel, if I can't step through it in the debugger, I can't be sure about it. Marshall.
So heavens don't turn on optimization.
Indeed, turning on the optimizer could be very dangerous. It messes with your code entirely. Yes. I trust library writers a lot, and I think that was true even before I had met any of them, but it's all the more true now.
Thank you.
This kind of fear, you can't bully someone into not being afraid. Okay? So if you make a rule that says, I'm going to fire you if you do these things, they may not stop because they're doing these things so you won't fire them. Okay? But that's not the source of all bad code in the world. There's so much bad code. Who quoted Anna Karenina? Maybe that was Kevlin this morning. It's all starting to blur. Was you. Happy families are all the same, but unhappy families are all different in their own way. Bad code is all different in its own way. So I showed you tiny variable names before, the A, the B, the D1, D2, D3. Sometimes they're just copying what the person before them did. Sometimes the obscurity is deliberate. I have heard people say, can't you figure it out? I thought you knew this stuff. Geez, we really should start hiring physicists, right? Same with the function names. An actual quote I have heard, why should I explain myself to people who can't understand it if I don't explain it? I can't argue with that, but I know it's wrong. And it's right there in the code. When I read the code and I see tiny little names, I know that one explanation is maybe, lacerated fingertips, don't want to type. But another explanation is, I can't care enough about you to give you any of the stuff that's in my head. It was hard for me to get, should be hard for you to get. And this brings me to F and G and foo and bar. F and G and foo and bar aren't just opaque names. They are laughing at you for wanting a name. They are aggressively anti-names, right? They're like, oh, you want the function to have a name? Oh yeah, we'll call it F. Feel better? Haha. Don't waste my time anymore. And when I'm trying to get stuff on a slide, they're very appealing because they're short. And the medium is the message, and I'm trying to get stuff on slides. But here's the thing. When I teach you how to write C++, and all my examples are F and G, what are you learning? Your first function is called F, and after that, we carry on alphabetically. Some people love foo and bar. I have grown to not love them. Not because of the swearing that is implicit in them, but because of the dark military humor from which they spring. They come from a time when people were literally dying, and the stuff that they had on their, it's Navy slang, so on their boats, was mostly, in some cases, broken, but they had to go anyway. Because if you run a Navy, sending a boat with half the stuff broken is better than not sending a boat. And having everyone on that boat die, but some of your mission get accomplished is better than not sending a boat, sometimes. It's probably horrible to be a general. I don't want to know. The people on the boats knew this. They knew their stuff was broken, they knew their orders were contradictory, and they made a joke out of it. They said snafu, situation normal, all messed up, and foobar, when things were messed up beyond all recognition. And it's funny, we're all gonna die kind of way, but we're not all gonna die. At least not today, and not while writing our software. So I don't care if you swear, but I don't want gallows humor in the code. So I dropped foo and bar from my life. You don't have to, but I did. The bigger problem with them is like F and G. They say names are for the weak. And they're not. Another explanation for raw loops, another explanation for not using algorithm. I used a sort in 1993, and it wasn't as fast as mine. So I win forever. And I'm going to write my own accumulate. Because, there's some real performance tricks in that one, right, Marshall? You got to tune it. Oh, it's tricky stuff. sometimes they're right. I will grant you this much, okay? We say it ain't bragging if you can do it. They may have a particular data set on which their weirdo sort that they invented themselves in second year is better than the standard library sort. They may. Yeah, they also probably don't, but they may. A lot of the time, though, they just have it in their head that they're better at this than someone who does it all day long. I don't know what to say. Then there's the other kind of bad names. Who's in a Slack equivalent? You see these things, right? Losers, right? L-U-S-E-R-S, losers. Oh, the losers are at me again. PEBCAC, the problem exists between the chair and the keyboard. It's a popular reason for closing bugs. And of course, RTFM, read the manual. And I know lots of programmers who talk this way about their users, about each other, and in some cases to their users and to each other. And in my experience, people who talk this way in Slack talk this way in code. The comments say, because Bill is a stupid. In fact, my favorite, again, I've slightly, it didn't say nonsense, okay? It said a different word that I don't want to put on a slide. I said Bill earlier, so let's make it Bill and Steve had a disagreement about how a particular business process should happen. It's a multi-step process, okay? And at some point, a file needs to be moved to archive, or maybe a record needs to be written to the database, or a particular field needs to be updated. And Steve thought these things should happen fairly early in the process and did them in his part. And Bill, who's writing a later step, felt strongly that that was wrong. So rather than settle the issue like adults, he just wrote this function to undo what Steve had done. Again, runtime cycles because of a human problem, right? And so as the process ran, Steve did whatever it was that he did, and then the function that Bill wrote got called, and then Steve's BS got undone. And not only was this considered by all involved to be an appropriate way to solve the problem, they had no problem labeling it accurately and precisely. Right? They didn't care who knew how they felt about the need to undo these steps that had been done, quote unquote, too early. And that's the most shocking part about it. If it was just called procedure correction or something, you wouldn't even notice. But when you read code and there's a person's name memorialized for all time, and I go in and I say, who is Steve, or who is John, or who is maybe some initials? And the oldest person there will go, oh, yeah, I'm not telling that story. Oh, okay, here's a thing. And, you can save people a great deal of money and pain and trouble with a question like that. So what these bad code behaviors have in common is arrogance. This is someone who thinks, I am better than my teammates. They don't deserve me. I know what's right and what's wrong and who's worthy of explanations. What I say goes, and we do things my way. That does not always make good code. It has got the possibility to make spectacularly bad code in a way that's very hard to fix if the arrogant person is still with the company. What else can I show you? How about, again, another explanation for not cleaning up? I mentioned that you might not clean up because you were afraid. Because if you took the time, you'd be too late on how many tickets a day you were checking in, how many lines of code a day you were checking in. Heck, if you're metriced on lines of code a day and you delete some, right, you're lowering your score. But there's also a different motivation than just plain fear, and that is like, you want me to spend my time for you? I don't think so. Same with the, I'll slam a global in, I'll stick a number in, we'll just use the constant. These people see their coworkers as competitors, not as teammates. And they don't have to outrun the bear, as it were. They only have to outrun the person next to them to be the best performer in the department. So literally, if I slow down my coworker, I'm the smartest in the department. And these people completely exist. Mutable global state, that's way easier than changing the signature of a bunch of functions. Public variables, none of those annoying getters or setters or thinking about business logic, just make it public, it'll be fine. It's selfish, as is holding all the information to yourself. How can I have job security? I'm the only one who knows how to do this. They cannot live without me. I'm a dragon on my pile of gold, right? I know the passwords. I know the file where the documentation is. I know what an M27 is, and nobody else does. If you're thinking that being selfish is a good strategy, I'd like to let you know it doesn't scale. So in the very small, you can be very selfish. You can write very selfish code. And you can get things done very quickly and appear to be a little bit of a star, but it doesn't last long. And rather like the mythological dragon on the ever larger pile of gold, what was enough last year isn't enough the next year. And so the person gets more and more selfish and their behavior gets more and more outrageous until eventually management has a quiet chat with someone like me. Says, would it be possible for you to come in and let us know whether this person really has us over a barrel or not? Would it be possible for you to come in and see if we really are able to get rid of our very selfish programmer? And usually the answer is yes. Yes, you can. So it doesn't scale. In the short term, it works. In the long term, it doesn't. Then there's this person. Do you know this person? Yeah, it works. Well, kinda, sorta, mostly. We have testers, right? Or the users, they know how to get a hold of us. Libraries, even a standard library, I can't be learning that. I got code to write. I got copy and pasting to do. Testing, I don't know how to do that. Scripts, look, if you think that stuff matters, you do it. I'm not doing it. I'm doing what I know how to do. Abstraction, isn't that like where you have to think in stuff? I don't want to think in stuff. I got copying and pasting to do. These people have no commitment to the future, not even future them, never mind future coworker. Whatever works now is fine. 15,000 line switch, whatever. It was okay when it was 13,000. I'm sure it'll still be fine. They're lazy. I mean, we're not all nice people. And I'm not talking about, wow, he's so lazy, wanting to go home at 5 o'clock and see the family. I'm sort of talking about 2-3 hours a day on Facebook and, on-the-job retirement. And they can get their deadlines met as long as they do a half-assed job. And everyone else is carrying for that. And I come along and I can see it in the code. Now, I mentioned crunch, and to be fair, people act like this during crunch, okay? If you make people work 18 hours a day, if there's a whiteboard in the lunchroom where you're tracking the divorces, and that's not a made-up story, that's a real story, people cut a lot of corners. They leave a lot of stuff off, and I do not blame them. But the crunch should end, and things should get better. And if people don't come back and clean up after, or if the crunch never ends, you make very bad code. Be aware of laziness, but also be aware that you can turn anyone into a simulacrum of lazy just by not giving them reasonable deadlines and crunching them all the time. So do you believe me? Your code is full of emotion. You got a business rule that says, if the due date is after today, the item is overdue, here is how we process overdue items. That does not have emotion. Right? That rule and the way you code that rule does not include, but you're a cute little kid, so I'm going to cut you a break. That rule doesn't include, and you're from a group I dislike, so I'm going to charge you a double fine. There's no emotions in that sense. But everything else about that code is so emotional. How are you representing date? Are you using some library type that was invented this century? How are you comparing that the date is before or after the due date? Have you written a function? Is it a member function? Of what? Everything about your code. The name of the variable, is it DD for due date? Or D2 for date number 2? Or is it due date? That all carries emotion to me. And I hope some of you now believe that fear and arrogance and selfishness and laziness can be on the screen jumping out at the person who reads that code. Now, another disclaimer. Sometimes the correct name for your variable is T or S or V or P. And that's okay. You're not a bad person. You look for a pattern of things, okay? But it's also about what you do with that pattern when you see it. So I have pain in my joints because I'm a woman of a certain age. And when I go up and down stairs, especially after a long day, I make little noises on the stairs. My granddaughter copies them. She thinks that's what we do. Oh, we're on the stairs? Okay, I know. This is how stairs work. It's very adorable from someone this size. If you and I were walking the stairs in this building and you happened to say, maybe your shoes were tight or something, it'd be really wrong for me to offer you treatment options for your joint pain and start telling you the story of my joint pain and what I do for it. One doesn't mean you have joint pain. It just means you said But a pattern is a different thing. And I look for patterns in code and I see them. It's also about what I do with it when I see it. I very rarely go to the person who wrote the code and tell them all about the emotional insight that I have gained into them. That is not the point of doing this. Here's why it does matter. First of all, the person who wrote the code is usually long gone. And we don't always think very nicely about the long gone person who wrote that code. We call them names that used to be actual technical medical terms like idiot and moron and imbecile, which they probably don't technically qualify for. But we also call them undereducated and foolish. And maybe they weren't. Maybe they were just afraid. That helps me feel a little bit better when I have to fix that code up. I can sort of say, hey, maybe you didn't even have source control. Like 2003 was a long time ago. A lot of people didn't have source control then. We do, so this is all going. Like, don't get me wrong, this is all going. But I just feel a little bit better. That makes me happier when I'm in that code. Because before I had this realization, I often thought that it was all the arrogant person. It was all the person who's actively working to make this hard for me. Now I understand there are lots of reasons why the code might be like that. But also, what if they don't have source control today? Maybe such shops still exist. So now the value I bring is not in fixing up their code, it's about teaching them that source control exists, or that build automation exists, or that unit testing exists, right? There are so many things I can do to a process that will make the code better by removing what is making that person afraid or crunched or whatever is causing them to write the bad code. And I can go to management for the budget because you're wasting CPU cycles, right? These people are undoing Steve's nonsense and checking things twice or 10 times. When we speed the application up, that can be our motivation for why we're going to not just fix up the code, but fix up the process so that kind of code stops happening. But I did also say, does your team need to change, by which I mean that some people should not be on some teams. And if you have that arrogant, selfish, or lazy developer still there, still writing blatantly bad code, sometimes being able to put your finger on the motivation for a lot of that code is the sort of crystallization of like, oh, we need to have a team that's a full team that all work together. and that are all supporting and helping each other. And yes, when I'm writing code, I'm asking myself, what is it showing? Does this code look arrogant? Does this code look selfish, lazy, afraid? Maybe I don't want to write code that looks like that. So could it be neutral code instead? Could I write code that was neither good nor bad, neither selfish nor generous? In some human interactions, we can be neutral. Shopping lists, for example, are generally neutral. I say generally. Have you ever angrily written something like in all caps and underlined it because someone used it all up? Mostly, though, they're pretty neutral. But think about a letter of recommendation or a love letter. They're not neutral. In fact, if I got a love letter that said, "How are you? Weather's good here. I think I'll go for a walk later." It's not really a love letter, is it? And it's falling into that damning with faint praise category of trying to tell me something. Not possible to write a neutral love letter. You either love the person or you're dumping them. You either want someone to hire them or you don't want someone to hire them. Otherwise, you wouldn't write the letter. I will put it to you that code can't be neutral. That if your code isn't selfish, then it can be generous. But there isn't some state in between. But even if there were, why is that what you're aiming for? What the heck? Let's aim for the good stuff. You can choose to be confident and capable instead of insecure and afraid. I want to write code that says, wow, this person knows what they're doing. And I know that following and reading along is going to get me to the right place. And while there may be a bug in it, it's still basically good code. I want to write code that's reassuring, that's transparent and obvious instead of being secretive or having just been thrown together with no plan. And I want to write code that's open instead of code that hoards its information like that dragon on that pile of gold, that explains itself to me as I go along. And if I can, I want to write code that is humble rather than arrogant. Humble is tough, right? You can't say, I am humble. In fact, I read, humility is like Zen. If you think you have it, you don't. Because when you say you're humble, you're like, I am actually the best person in the whole room, but I mostly don't say so. Which is not a very humble thing to say. But you can write code that is humble. And you can write code that is generous and giving and caring. And I would rather see that all day long than code that is selfish and self-centered. I live in Canada, minus 5 points to everyone who thought I was American. It snows in Canada. Still some snow there right now, as far as I know. And the roads get slippery, and our cars go into skids. So we all learn how to deal with losing control of the car you are driving when you don't have traction anymore. And you can go to like skid pens and officially learn how to do this, but most of us get by with these words: look where you want to go. Because if you see like a tree or another vehicle or a guardrail that you are headed for and you're worried you're going to hit it, and you lock your eyes onto it, you hit it. We teach our children, look for something that is a gap, that is not a tree, that is not a vehicle. Pay no attention to the thing you don't want to hit. Stare at the empty space, and your hands and feet will kind of automatically take the car there. And I've had occasion to do this, and it works. It is literal advice. Like the look in this advice involves pointing your eyes and receiving signals in your brain. The where you want to go refers to the future position of the moving vehicle in which you are contained. But it screams out to be a metaphor, doesn't it? Like, focus on what you want, not on what you don't want. So I showed you bad code from fear and selfish and laziness, arrogant people. What if I show you good code that's the opposite of all of those things? I have source control. And I also have what I call work notes. So if I'm going to add a new screen to a system for a customer, I open this document called Add New Screen. It's got all the specs and diagrams and photos of whiteboards and whatnot in it. And then as I go, if I have any problems and I have to look up documentation on the great bathroom wall of the internet, I put the links in there so I can find them again. And if I delete some stuff as part of what I'm doing, discovered the calculate fudge factors routine is never called. Not only do I delete it, but I make a little note in there so that if it turns out later we needed it back, I'm not trawling the source control. I got work notes. I take the time to clean up because I'm confident enough to know that this can go, and I know that there is a penalty for the next 20 years of people reading stuff and trying to figure it out and then realizing they didn't ever need to read that or figure it out. So for me and for others, I take the time and I clean that stuff away. I put in comments if I need to. It's better to do my explanations in names, to give the variables good names, to give the functions good names. But if I have to, I'll use a comment. And if you're at my nothing talk, we talked about the times when the only way to explain what you're doing is with a comment. But my comments, they're not the don't blame me, go talk to Steve in accounting comment. They're the comment that says, I know how this works. Let me take a moment and show you because I know this is how this works. And I will fix things that are old and wrong. I'm not going to go change your spaces to tabs or your tabs to spaces or fix your brace style or any of that nonsense. But I will give a variable a better name. If I'm reading through some code segment and I suddenly realize what D3 is, I will refactor D3 to the correct name right there. If I puzzle my way through a loop and understand, this is all of, I will call all of instead. Right at the moment that I have learned that information. Because while it cost money for me to learn it, I had to do that, right? It really doesn't cost anything for me to record my learning, which is the step most people skip. I'm going to show confidence. When you know what you're doing, these things are super easy to do. They're only hard and scary when you're not given the time to know what you're doing or when you just haven't yet managed to learn what you're doing. So if you do know what you're doing, you can leave that in the code. You've all read something by someone who knows what they're doing. Try to write that. I'm pro-library. That's probably not a shock to anyone. Use libraries. And if it's not the standard library, then somewhere, please leave someone a link. Who knows someone who went away to write a JSON parser over the weekend? Did they succeed? Yeah, that's the answer I always get. Yeah, it's like Thursday afternoon and someone's like, we should be using JSON for this. Yeah, you're right, we're gonna need a JSON parser. I think I can whip that up. It's a pretty simple format. Yes, we are the first. But when you choose the best JSON parser, and also please don't be the person who needs 6 weeks to choose the best JSON parser, toss a link somewhere, just so that the rest of us can find out which one you chose later. When I write comments, write gentle comments, by which I mean helpful comments that are not sneering at anyone, they're not putting anyone down, that are actually there to be helpful. I found these in the wild, I like them. This code is very rich in magic numbers, and you could maybe argue that it shouldn't be so rich in magic numbers, but the comment kind of allows me to forgive it. And if you're not a Windows programmer, and especially not in the particular use case of an MFC application that's having some WPF added to it, which is where I found this, it says set the page size to the standard 8.5 by 11, and then explains that 96 is the dots per inch, or DPI, for WPF. Windows Presentation Foundation, a .NET technology you don't often find being used in MFC apps. But it has the advantage that WPF control vendors are still in business, and not very many MFC control vendors are still in business. So if you want to use graphs or something from a library, very cheap and quick and easy, you just add a WPF control into your MFC app. And then we set the page height to 8.5 times 96 and the page width to 11 times 96. And in fact, when I found this code, they were in the other order. It set the width and then the height, because I think that's how we talk. But because the comment said 8.5 by 11, and because in North America that is the idiomatic way to say a standard sheet of paper, it made sense to have the 8.5 code line come before the 11 code line. And that's what I mean by a gentle, thoughtful comment. Tiny little touch about thinking about the next person and setting it up so that it'll all make sense to them. Names, names, names. This code says, I know you're my peer. I know you're worth explaining to, so I'm going to explain to you. You deserve it. This code shows humility. I love when I find this stuff, and I get to do it sometimes. Some real engineering. You know, we're always telling people they should strive for an appropriate level of abstraction. It's like the weaseliest of all weasel words, right? Not too much. Don't want to be an architecture astronaut. Let's add another level of indirection. But not too little. But, you know, I may not be able to define it, but I know it when I see it. And when I see an appropriate level of abstraction, I'm like, oh, that's nice. That's really elegant. That's saving us all time and effort. Good work. Not encapsulation like, oh, we have 27 member verbals, so we'll have 27 gets and 27 sets. That's not well thought out encapsulation. The kind of good encapsulation where stuff is tucked away and invariants are preserved and someone's thought about how this all works. Again, someone who's cleaning up, splitting huge functions into smaller things, rearranging things so that all the initialization is together and all the cleanup is together. Really putting some thought into what these lines of code do in the bigger picture, the exact opposite of writing a comment that says increment I by 1, right? Connected to that business world. This person says, my job is safe if we can all do this. Not to mention that I can get promoted if we can all do this, but you know, my job is safe if the company stays in business. It's a good prime motivator. This code shows generosity. Names. Who thinks we're good at naming? No hands. The AV guys are not putting their hands up. They know we're not good at naming. We're famous for it because it's hard. That's why RAII stands for Scope-Bound Resource Management. You know why we're so bad at it and why it's so hard? It requires empathy. In order to name something, you have to imagine being the person who's using it. So if I have a 10,000 line function and I grab a couple hundred lines and stuff them in a function of their own, I am the person who's using it. It's a pretty easy identification for me to make. And from that position, I know what this code does. It updates or ships or marks or archives or some verb, right? And I can name that function. That's cool. I'm in the middle of figuring out whether or not your item is overdue or not. I know what everything is. That's the due date. That's today's date. That's the date difference. This is the penalty. Easy. Now I'm going to write like a API for the outside of a class that a lot of people are going to use that aren't me. And I have to think about what to call that stuff. Is X and Y okay for coordinates, or should it be horizontal or vertical? Should I put some decoration in the name to let you know which way is positive and which way is negative, or whether this is in inches or pixels or whatever? Suddenly it's a much tougher job. And then imagine that you write like a public-facing API that's called by different applications, maybe by people who don't work for your company. It gets really hard to think about what to call that. You have your own like internal inside name for stuff, but that may not be what the consumer of your API wants to call it. So the more generic we get, the harder it gets. And I can tell this next story because you know I love algorithm, the header, right? I mean, I'm not Sean, but I'm right in line behind Sean. And I was telling someone who's technical but not a C++ person about how I'm always feeling like, wow, they thought of everything. So I told the story of sort. That's a really easy function to understand, right? In its simplest form, you give it the range that you want to sort, and you can even by default leave the predicate off, and it'll just sort them from smallest to biggest. But you can provide a predicate if you want. So if you have a vector of employees, and each employee has a total sales volume, you can sort these so the people with the largest sales volume are first in the collection, all the way down to the people with the smallest sales volume. And it's a pretty easy thing to do. You can write a lambda. I love lambdas also. Sort makes perfect sense, and it's easy to teach. But we're all about performance. If I have 1,000 employees or 10,000 employees, and I want to know the 5 people who made the most sales, I don't care who came 998th and who came 999th and so on. I don't want to pay to sort the unwashed masses, as it were. So that's cool. We have partial sort, right? So with partial sorts, the appropriate parameters, let's say the 5 with the highest sales volume would be 0, 1, 2, 3, 4 in the collection, and everybody else, the unwashed masses, would be in some kind of order. That doesn't matter to me, but they wouldn't be in those first 5 positions. That's good. That's a great function. Glad we have it. But why do I have a vector of 1,000 employees anyway? What am I doing with this thing? Well, maybe I'm showing it on the screen or something, right? And it's probably in an order. Like maybe it's in order by last name. And if I permute it in order to bring those high-performing people with the big revenue to the front, I'm going to have to resort it to get them back into their alphabetical order. That seems like a waste of time. I could take a copy of the whole big collection and partial sort that and then throw it away. But that also seems like a waste of time. But hey, we have a thing called partial sort copy. Yay. You know what it does? Really? Astonishing that the person who has to write one knows what it does. It takes just those top performers, they get copied into the different collection, the target collection. Your original collection is unpermuted, ready for you to continue to do whatever you were doing with it. That's fantastic. Who thinks this is a great function? Of course you think, I just told you it was a great function. Put your hands up. It's a great function. But who already knew about it? Less hands. You know why? That's a terrible name. That name only makes sense if I tell you that story. If I start with sort, then explain the problem with that and I tell you partial sort, then tell you the problem with that, make partial sort copy, then you're all like, so logical, so clever, such prescience. But what if it was called top N? Then you would have just found it on CPP reference. That's what I want. I want my top 5 performers. Excellent. That's my function. What the heck is partial sort copy? You're not choosing that. Talk about this is obviously a rotate. Well, this is obviously a partial sort copy.
They're not sorted.
I'm making that up. That's what I'm saying.
But top N is not sorted.
Top N might or might not be sorted. We can call it top ordered N if you like. I'm making the name up. My point is that partial sort copy is written from an implementer's point of view. And remember, I love implementers. But that is the implementer name, because that is what it does, and that is what it builds on, right? But top N is what a consumer wants. And that is a really, really hard thing to write if you've never been that consumer and don't think the way that consumer does. And don't even start me on trying to imagine what 40 years from now consumer wants to call the functions you are writing. Like, I'm not saying it's easy to get names right. My point is in fact spectacularly difficult to get names right. It's worth doing. It's hard. Here's an easier name change. This is a real tweet. Travis here is telling Jessitron that, presumably at Jessitron's suggestion, I went and renamed my variables that only my programmers see. from error message to help message, and I'm writing better messages. Now, I probably would not have bet on that. I would have said that would not happen. But see, something switches in your head. When I give you an error message, I tell you what's wrong with you and why what you did is an error. When I give you a help message, I'm offering to help you. Well, who cares? Logically, that's the same. You might think so. I might have thought so. I offer you this experiment. I bet you have a code base with error messages in it. Consider doing this. It can't hurt. Maybe it will help. Because it's bringing out your empathy, which you have because remember we proved that you are a human with emotions. I know, you don't want it to be true. Here's another kind of code I love to find. Code that compiles and links and runs and passes the test. And I really mean it. Because you know the code that mostly compiles? There's 117 errors. No, warnings, because we don't turn on warnings as errors because that's dangerous. And you just have to pay attention. One day there might be 118 warnings. That wouldn't be good. But as long as we're at 117 warnings, it compiles. And yeah, when you run it, sometimes it throws an exception, but you can just hit continue. It'll be fine. It's fine. No problem. Every time you run it, every other time you run it, on Tuesdays, it leaves a file in this working directory. And if you don't delete that file, the next time you run it, it'll blow up and you can't continue. So you have to remember to delete that file. This counts as working, sorta. So when I say it compiles and links and runs and passes the test, I mean those things in the absolute extremity of their truthiness, okay? It compiles with no warnings. It links with no warnings. It runs with no exceptions. It runs with no hand cleanup required afterwards. And not only does it pass the test, but I'm not talking about all 7 of them either. It passes a reasonable, realistic, useful test suite. Yes, now I'm happy. Someone has taken the time to do it right, not just close enough. I see modern things in there. Ooh, libraries. It's so 21st century. But I also see maybe some ranged for loops where that's appropriate. Maybe I see some lambdas instead of function pointers. Maybe I see some, the many substitutes for macros, like functions or aliases or actual working code. But at the same time, and I admit that this is hard to measure, I'm not getting that this person's just having fun with the new toys vibe. I see that this is the right thing to do here, right? That they've chosen this modern construct because it's the exact sort of thing we invented this modern construct for. And they're like, yes, this is where I'm going to use this. And that's good. They're not just copy, paste, more code, more for loops. I have a for loop just like this somewhere else. I'll bring it over. It'll be great. This person shows a commitment to the future, to making life easier for themselves while they're writing it, to themselves tomorrow when they're debugging it, to someone else a year from now. They'll put in the effort to make that effort get saved. I'll put in 10 minutes to save an hour a year. Yes, I will. This code is hard working. I want to show those positive emotions, to show generosity and humility and hardworking confidence, because the code will just be easier for other people to read. Because generous code is easier to read than selfish code, right? Well thought out code is easier to read than slapped together code. And it'll be more fun. You're not going to be reading about the long ago Jim who was such an idiot because you took that away. You're not wading through the worst. It's 12 pages of mostly commented out code, but every once in a while there's a line that's not commented out. I hate those. You will enjoy it so much more. And if you're producing this code, not only are you enjoying reading it, you know a lot of other people are enjoying reading it. And they're remembering who made this. Hey, I thought code was supposed to be horrible, but whenever I read one of Kate's functions, I understand it and stuff. Yeah, I think your code will actually be better. I think I can prove that you will have a better runtime performance, that you will have less bugs. We've had other talks about that. But this is actually, we're talking about emotions in code. So even if your code doesn't get better, look at the benefit of writing this happier code rather than the miserable code. So what do I want you to do? Step 1, care. And we're all too cool for school. It's great, I don't care. Care. Start by caring about the person 15 years ago who wrote that code that you're reading and thinking of them as an actual human with a real life and who was worried about getting fired or was worried the company was going to go under if they didn't make the deadline for holiday 2006. And care about them and then fix what they couldn't fix, right? When you know your stuff, put that on the page. Show your confidence in the comments you choose, in the names you choose. You can actually leave this trail that says, this is someone who knew how this stuff works. And be generous with that knowledge. When you get it, give it. Saying be empathetic is easy to type, real hard to do, really worth doing. Those of you who can do it and can put it in your code will go far. People may not quite know why. I don't ever expect you to get a performance review where someone else goes, and you know what? That function you wrote to batch process the old reports, it was just blindingly empathetic. We all loved it. I get that, but do it anyway. You're going to show emotions in your code, whether you like it or not, whether you mean to or not, whether you know it or not. So they might as well be positive ones. Please and thank you.